All right, so welcome to our first video. Today we're going to get into our first lesson, tools of algebra. And generally the plan is to kind of have my face in the video so you can have an opportunity to kind of see my facial expressions, kind of get a better look at what I'm trying to um, relate to you. But for this video, for our first one, I'm just going to let you have my voice. And it's the tools of algebra. The objective, we're going to graph, order, and use real numbers. So we're going to look at the real number system. We're going to order and compare numbers. And then today we'll actually do the opposites and reciprocals. For tomorrow, part two of this lesson, we'll do the properties and we'll do the real number operations. So for today, we're going to start with what are real numbers. And when we look at the real number system, here. Real number system includes all rational and irrational numbers. And kind of what's an irrational number? Irrational, something a lot of times if somebody's irrational, you kind of say, that person, they're irrational, they're not making sense right now. And if I look at a number like uh, 5.39862745, that's not a number that I can really get a grasp of. It's just a wild kind of number. So irrational numbers often they cannot be written as decimals, or they cannot be written as decimals that terminate or repeat. And then, but we also have the rational numbers, and we start with just our whole numbers, our regular counting numbers: 0, 1, 2, 3, 4, 5. We move up to our integers. We have -2, -1, 0, 1, 2. Now, the difference between the integers and the whole numbers are whole numbers are only positive numbers. Integers are positive and negative whole numbers. But the one thing about integers is there is no integer between 1 and 2. There's no integer between -1 and -2. Integers are only positive and negative whole numbers. Anything in between there, the decimals and the fractions, would not be an integer. And then we look at fractions and repeating decimals. So 1/4, 4.25, 0.33 repeating. These are examples of numbers that you can kind of comprehend. 4.25 is 4 1/4. 1/4 is a quarter. 0.33 is a third. These are numbers that we're kind of accustomed to working with. And so they are rational numbers because they kind of make sense to us. So when we look at this graphic organizer, is 4 an integer? Well, yeah, 4 is inside the integer box technically, as well as it's inside the fraction and repeating decimal box, and it's in the rational numbers box. So, however, is 1/4 a whole number? No, 1/4 is not in the whole number box, but 2 is in the fraction and repeating decimal box technically. So that's the way this graphic organizer works. And as we take a look at our first objective of the day, we're going to graph real numbers on a number line. And a lot of times I look at these numbers and they're very difficult to make sense of. And my recommendation always is, let's convert all of these to decimals. So we have them all in the same form at least. So we have -2/3. I punch out of my calculator here and I get -0.66 repeating. And 7. I don't really need to punch 7 in my calculator. I know where 7 goes. I keep hitting the little button there. However, square root of 5. I know the square root of 4 is 2. The square root of 9 is 3, so it's probably 2 point something. But I'm going to get my calculator out here, and I'm going to punch in, let's see, clear. I'm going to punch in the old square root 5. And the square root of 5 is 2 point, we'll just go with 2.2. That'll be plenty specific for us. And then finally, we have 7 over 4. And if I punch out in my calculator, I do 7 divided by 4. And I get 1.75. 1.75. So now I can go back and graph these last three. So negative 2/3, that's a 2/3 is less than 1, but greater than 0. So negative 2/3 would be right around here. Negative 2/3. 2.2, or the square root of 5, would be right here. So we're going to mark that square root of 5. And finally, 7/4. 1.75 right here. We're going to mark that as 7/4. And that's our answers right there. If I wanted to highlight them a little bit, just so we can see, we have our 7/4, our square root 5, and our 7. And then I move over to, actually, let's go with the red here. Get the red, I did. -2, I don't really need to convert that to a decimal. I know -2. -5, we're not going to convert that to a decimal. 3/4, if I wanted to, I punch out of my calculator and I get 0.75. So that's going to be between 0 and 1. Right about here would be, what was it, 3/4? Oh, another decimal, now we have an improper fraction. So I do 5 divided by 4 in my calculator and I get 1.25. It's going to go right about there. 5 over 4. And then finally, oh, we got the number 1. There we go. That's what they say about me. I'm number 1. There we go. And a little arrow just showing that the 1's the point in the middle there. So this would be the easiest way for you to do your homework tonight. Get out your calculator, convert these decimals, and then go right ahead and plot them. And then we're going to order, oh, I forgot to finish the directions. We'll say least to greatest. Again, some of these I could want to convert to decimal. Like, for instance, maybe -5 over 2. That's going to be -2.5. So what's our biggest negative number here? We got 2.5, 2, 1. So it looks like it is -2.5 is our biggest negative number, so it makes it the least number of the group. We move to -2, -1.35, -1, and our only positive number is 4. And because my writing's a little sloppy, I just want to box my answer in, so tell what I'm working on here. Oh, we have -5/2 again for the bottom. So that's again -2.5. Square root of 7. Let's punch that in the calculator. And I clear my calculator. I hit my square root 7, and we get, we'll go with 2.6. So if I want to find out what's my least number here, I want the largest negative number. So that's going to be -3.5. Next would be -3, followed by -2.5, which is -5/2 in our given numbers. And then now our two positive numbers, we have 2 and 2.6. So the next least number would be 2, and then our greatest number would be square root 7. So again, converting these to decimals, putting them all in a similar form, the easiest way generally to solve these. And finally, the opposite of 3 is -3. The opposite of -6 is 6. So whatever a number is, if it's negative, the opposite is positive. And if it's positive, the opposite is negative. So we're just, the opposite numbers are just the positive and negative form of every number. Reciprocals here. Now, technically 3 is 3 over 1. And we flip them, numerator, denominator, denominator, numerator, and we get 1/3. Down here, we see 3/4. Reciprocal is 4/3. I could have something like -5. And the reciprocal would be, again, I could put that over 1 if I wanted to, and that'd be -1/5. So reciprocals, we're just flipping the fraction. We keep the sign. Eventually, we're going to look at opposite reciprocals, but we're not there yet. Identify the opposite and reciprocal of negative 1/4. So the opposite of negative 1/4 is positive 1/4, and the reciprocal of negative 1/4 is negative 4/1, or negative 4. We move on to the bottom one. Identify the opposite and reciprocal of negative 5. The opposite of negative 5 is positive 5. The reciprocal of negative 5 is negative. Instead of 5/1, we're going to do 1/5. So our opposite and reciprocal. So this is all we have for today. And then you're going to move on to your homework, which is about 7 questions, I believe. You can find that on our Canvas where I will input this video. But looking at our tools of algebra for tomorrow, the 14th, you will see we have this little worksheet right here. It's about 7 questions, and you can take a picture of your work. You can scan your work, whatever. Just send your work back to me. But this will be your homework for tomorrow. So if you have any questions, again, you can stop by and see me at 9:30 at office hours. Otherwise, I hope you were able to understand the lesson and have a great day.